Hello, and we are going to go through the Chapter 7 review packet and a few questions from the Chapter 7 multiple choice review. Feel free, if you receive an answer that's correct, you can fast forward through the explanation of that problem, or feel free to take another listen if you are unsure how to get the answer. So let's start with number 1. Under the 7.1 multiplying polynomials subject, determine whether each expression is a monomial. Explain. So in order to have a monomial, we can have no addition or subtraction signs, no negative exponents, and then we also cannot have division of a variable. So let's take a look at a few from the first section. Number 1, part A. This would be a monomial because it is just a constant. It would satisfy all the requirements and therefore would be a constant. B would not be because of the addition sign. Okay, let's look at the second portion of 7.1, simplifying, so multiplying monomials. So let's look at 2, part A. I am going to multiply my coefficients of 6 and 2 to give me 12, and n to the third times n to the seventh will give me n to the 10th. Because when I multiply exponents with the same base, I really just add their exponents. Okay, let's look at the third portion under 7.1 still. So simplifying, and it looks like here we have power to a power. So I see in part A, 2 to the second, to the fourth. So I'm going to, again, and I'll zoom in here, I like to draw a circle around all my exponents, and that tells me to multiply them together. So 4 times 2 is 8. Times 2 is 16, so this really equals 2 to the 16th, which is 65,536. All right, we're going to skip over number 4, but you can certainly complete that on your own, and let's look at number 5. So we have a monomial times a monomial, but it's just got a lot going on here. So let's take a look at the first monomial. I'm going to cube everything that's inside of those parentheses. So 1 over 2. So 1 cubed over 2 cubed, a to the 6th, b to the 6th. And if I want to simplify that a little bit further, 1 cubed is just 1, 2 cubed is 8, a to the 6th, b to the 6th. And then let's look at the second monomial. I'm going to simplify my power to a power, and that changes to 4. Now distribute that 4 to everything inside the parentheses, and I get negative 4 to the 4th power, which is 256, b to the 4th. And now I need to simplify 1/8, a to the 6th, b to the 6th, times 256 b to the 4th, and I'm going to take 1/8 of 256 to give me 32, and then a to the 6th, there's no other a's over here on the second monomial, and then b to the 6th and b to the 4th give me b to the 10th, and that is my answer. Alright, now let's look at a few problems from 7.2, dividing monomials. So let's look at portion 6, and let's look at 6a here. So I'm going to, when I divide exponents with the same base, I really am subtracting their exponents. So if I look at part A, I have x to the third over x to the second, so I'm going to cross out 2 down in the denominator, take away 2 in the numerator, so I'm left with 1. Take away 1y in the denominator, and I'm left with y cubed. So my final answer is x, y cubed. And let's scroll down here to C. So we're going to skip over B, but you can complete that on your own. And I am going to now distribute the 3 to everything inside those parentheses, because that's to the exponent of 3. So I get 3 to the 3rd power, x to the 12th, all over 4 to the 3rd power. Now let's simplify. So 3 cubed is 27, x to the 12th, all over 4 cubed, which is 64. That's my final answer. Okay, now we'll look at question 7, simplify, and we are going to specifically look at question 7c. So the big part about this problem is knowing what to do with negative exponents. If I have a negative exponent, I'm going to circle it and flip those to the other side of the fraction. That's how we if we have a negative exponent, we will receive a positive exponent. So if I flip those variables with those negative exponents, what I get is I get w x squared y to the 6th all over w v to the 3rd. Now what I need to do is I need to simplify. So I see a w over a w, those cancel out. I see nothing else I can simplify. So I get x squared y to the 6th all over v to the 3rd. Scientific notation. All right, let's take a look at 8a. So I need to write or express in scientific notation this number here. So I'm going to write 6.87 times 10 to the, and I have to count how many decimals or place values are after my decimals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my answer is 6.87 times 10 to the 10th. All right, let's look at 9, part B. Now I have to express in standard form. So 9.03 times 10 to the negative 5th means that I move my decimal 5 places to the left. So 1, 2, 3, 4, 5, which means I really have 4 zeros in front of that 9. Question 10 says evaluate, write in scientific notation. So A and B are either multiplying or dividing with scientific notation. We are going to look at 10A here. So evaluate, write in scientific notation. Let's multiply 1.95 times 7.8. That gives us 15.21. Now with my exponents, since they have the same base of 10, I'm going to add those. So I get negative 8 plus negative 2 is really negative 10. So I get 15.21 times 10 to the negative 10th, except here we cannot write 15.21 because that number has to be between 1 and 10. So I'm going to change that by moving that decimal one place over and get 1.521. And then because I moved my decimal 1 to the left, I wanted to go 10 to the left originally, so now that lowers 1, so it becomes 10 to the negative 9th. Now let's take a look at 7.4 polynomials. So 7.4 begins with question 11, and the first part of 11, if we look at part B, says identify if the expression is a polynomial. If so, write monomial, binomial, or trinomial. So if we look at part B, I notice that they don't have any negative exponents, no division of a variable. So I do have a polynomial, and I see 1 and 2 terms. So this would be a polynomial, and if I were to classify it, it would be a binomial. And again, because that has 2 terms. Number 12 says classify or find the degree of each polynomial. So we will look at 12b. And so to find the degree of a polynomial of multiple terms, I need to find each term's degree, and then whichever term has the largest degree would be the degree of that entire polynomial. So if I look at 2xy, that degree is 2. Negative 3xy squared is 3 again because I add x to the first power plus y to the second. 2 plus 1 is 3. And then the third term, it would be 4, and 13 does not have a degree, so the entire degree of this polynomial would be 4. All right, 13, write in standard form. Identify the degree and leading coefficient. So standard form means highest degree to lowest degree. So this would be 4x to the 4th minus 2x squared minus 3x plus 8. The degree here would be 4, and the leading coefficient would also be 4. And again, leading coefficient's the first number that you see in front of your variable, and then the degree is the largest degree here. It's 4. Okay, let's look at 7.5, adding and subtracting polynomials, and let's look at question C. So find each sum or difference. So I'm going to look at my like terms, and I could again use the horizontal or vertical method. Here I'm just going to notice what I have for like terms and add or subtract them. So I have 4x cubed minus negative 2x cubed, and 4 minus negative 2 is really 6x cubed. So I'll write that the answer above that problem. Then I look at now negative 3x squared minus x squared to give me negative 4x squared, and then 6x minus no other x, so plus 6x. And then last thing I look at are the numbers here of negative 4 minus negative 2, which chop really is negative 4 plus 2, which is negative 2 for my final answer. 7.6 says multiplying a polynomial by a monomial. So let's look at under 7.6, question B. I'm first going to distribute the numbers that are in front of my parentheses. So I get 15x squared plus 6x minus 12 minus 7x cubed minus 2x squared plus 3x. Now I'm going to combine like terms. So let's see what we have here. I have 15x squared minus 2x squared. I have 6x plus 3x, and I have no other like terms. So if I combine my final answer and write this in standard form, I have negative 7x cubed, and then 15x squared minus 2x squared would be plus 13x squared. And then I have 6x plus 3x to give me 9x, and then minus 12, and that would be my final answer. 7.7, multiplying polynomials, is our next subject. So here in 16, find each product. I could find the product of two binomials, a binomial and a trinomial, or two trinomials. So let's look at question C here, and I have a binomial multiplying by a trinomial. So I'm going to use the box method here and make a 2 by 3 box, and I'm going to write on the side 3x minus 5 and 2x squared plus 7x minus 8, and put the product of the two terms inside the box. So 3x times 2x squared is 6x cubed, and then 21x squared, negative 24x, negative 10x squared, negative 35x, and positive 40. Then we can look at if we have any like terms here, and we should see those diagonally. There's one, and then there's another. Let's combine those like terms to get our final answer. So my final answer will be 6x cubed, negative 10x plus 21x squared is plus 11x squared. Negative 35 minus 24x is negative 59x. n plus 40. And that is my final answer for question C. All right, the last subject is 7.8 special products. So under question 17, let's look at part A. 8c plus 3d squared means I really have two binomials, 8c plus 3d, being multiplied by each other. So this is the square of a sum, or I could use FOIL or the box method, but I'm going to use that method that we learned to multiply quickly with that special product. So this is where you square your first term and get 64c squared, square your last term and get 9d squared, and then your middle term is 2 times your first term times your last term, and 8c times 3d is 24cd times 2 is 48cd. And that's my final answer. Let's also look at question E under 17, and 3m plus 2 times 3m minus 2 is the product of a sum and difference. So this is where your middle terms will cancel out, and your final answer will be your square of your first term, 9m squared, square of your last term, which would be 2 squared is 4, and then the sign in between those binomials is a subtraction sign because you have one positive and one negative to multiply, so it's 9m squared minus 4. Now we're just going to take a look at a few multiple choice questions. So let's take a look first at number 5. Number 5 reads, which monomial represents the number of square units in the area of a circle whose radius is 4x cubed units? If you can recall, the formula for area of a circle is pi r squared. So here I know my radius is 4x cubed, so I will write pi times radius of 4x cubed all squared, and now we just need to simplify that squared to everything inside the parentheses and get pi times 16x to the 6th. So if I rewrite that to find my answer here, it would just be my coefficient first, 16 pi x cubed, so that answer for number 5 would be A. Let's take a look at number 17. Each side of a square x units long is decreased by 9 units. Which expression represents the number of square units in the new square's area? So if I have a square and I am being decreased by 9 units, if x is my original length of a square and I'm decreasing it by 9, that would be x minus 9. Same thing on the other side, since it's a square, all sides are the same. And then now I just need to find the new square's area. So x minus 9, the quantity squared, and this is again a special product. So x minus 9, the quantity squared, gives me x squared minus 18x plus 81, which would be answer C. So please feel free to work on the rest of the review packet and the multiple choice questions, and check the answer key on Google Classroom. Let me know if you have any questions. Good luck!